So we have multicollinearity and the VIF. So for I told that multicollinearity is when the two or more producers are correlated with each other. So now we're going to be checking the correlation between age, LWT, PTI, and FTV. So we're going to plot a correlation matrix. You can see the bet data. We are subsetting these particular variables, and we use the core function on these particular variables that we have. For first of all, let me just run this. And we have continuous VAS. So you can see these are the variables that we have here. Then we now plot a correlation matrix of this. So if we check the core function now, so you can see that this particular argument that we have here, use, is an optional character string giving a method for computing covariances in the presence of missing values. So this must be an abbreviation of one of the strings: everything, all observation, complete observation, na.all complete, or pairwise complete observation. So this is the correlation matrix as you can see it now. So let's visualize this. Better usually visualize it. It's easy to see and observe correlation between variables. So I'm going to use the core plot package and use the core plot function from the core plot package. You give in your correlation matrix, which is this particular value. Then the method is going to be number. Then the type is going to be upper. So we're going to get only the upper in the graph, and you give it a title of correlation matrix. So I'm just going to run this. Let's visualize this and see what's happening. So you can see it here, the correlation matrix. So you can see that these values are not actually correlated. There is no multicollinearity. Most of them are not correlated with each other because you can see they're all faded. I think the highest correlation that you can see here is 0.22. So which means that these values are not correlated with each other. So that's a good sign. So we don't have any multicollinearity in our data. The second option is for us to go with the VIF. We're going to be doing it on our model object. So now let's run this particular VIF. Let's see. So these are VIF values. So we're trying to interpret this VIF value. These are the values we are trying to look at. These particular ones on this column. So these are this one particular one that you're looking at is the raw generalized variance inflation factor. So when your degree of freedom is greater than 1, you do not interpret this particular one. Like in some cases, we have raised to be greater than 1. But if it is not greater than 1, you can actually use it. But this is what you should actually use in practice, this particular value here. So you can see almost all of them are all 1, 1, 1, 1, which means they're all less than 5, which means in each of them there is no multicollinearity, which also corresponds with our correlation plot that I showed you earlier on. So you can actually visualize your VIF values. Just visualize it. So if they're actually greater than 10, it should show red. If greater than 5 or equals to 5, it should show orange. Or else it should show what? Light blue. So you can see everything is showing light blue, which means that none of these VIF values is actually greater than or equals to 5. So that's it. We have used a bar plot. So I already put our AB line, these lines that you are seeing here, to be the threshold of the value 5. So as long as our VIF values was actually greater than or equals to 5, you will have seen one of these particular columns is going to be showing red or orange.